Welcome to the lecture series on Big Data with Hadoop. Today, as part of this series, we will be covering join patterns. So, what is join? Basically, when we want to club two different data sets or two different tables in a database, we generally use joins. When we apply joins in database, it is most simplest part which we can make it out. But when it comes to MapReduce, as MapReduce has a limitation to work with only single key value pair, so the execution or the implementation part is going to be somewhat tricky. So joins coming to MapReduce, it is not that much simple as we apply joins in RDBMS. And as the limitation is MapReduce works on single key value pair coming from a single input file, but as per joins we need to work with at least two data sets. At least it might be any number of data sets. So at least two data sets are required, which will be in a different structure. So combining these two structures or two data sets which are large and complex, it is itself a big challenge. So to make it out, we are going to design a pattern through using which we can make it out join in MapReduce. So as join operation, prior to applying join operations, we are not going to filter any sort of data. So if the data set is of 1 terabyte and the other data set is of 1 terabyte, then we have to apply joins on 2 terabytes of data, which itself is a burdensome for the network, where overhead is going to be generated. So to have a brush up to joins, let us take an example. If we do have two tables, table A as well as table B, where table A we do have three fields, out of which user ID is treated as a foreign key as well as primary key over here, and in table B user ID is treated as a foreign key, which I am referring it as F. So when we are going with joins, firstly we will see inner join. How inner join will be applied? Common IDs or common field in both the data tables, such as 3 is common in both the things and 5 is common. So we can club the common entities or common fields in both the tables, and this is formulated 3355, whereas this row joined with this row, same row joined with this row. So two records will be generated, clubbing of table A and table B based on a field of 3. If you are going with the field of 5, then it will club with this as well as this. That is been the output over here when it comes for inner join. Similar elements in both the tables are going to be taken. If you are going with left outer join, then entire table of A will be there in the left part, whereas the similar elements such as 3, 3 and 5, 5 will be there. But what about 4 and 9? We don't have any similar elements which matches with 4 and 9 user ID. Then for those fields, we will be having null value from second table. Moving forward, right outer join. In right outer join, whatever table which will be on the righter part, we will have all the elements 3, 5, 8. 3, 3, 5 and 8. Whereas coming towards our left side of the table, the common elements 3, 5 will be there, whereas coming to 8, we don't have any 8 in the user ID. So for 8 field, we will have null values on the righter part. This is all about your right outer join. If you are going with full outer join, then we will have all the elements from right table as well as left table, such as the unique elements are 3, 4, 5, 8 and 9. We do have 3, 4, 5 and this is our 8th record and this is 9th user ID. But wherever there are dissimilarities, there will be coming up with null values. We will be coming with null values. This is all about your full outer join. So after brushing up with all these joins, how to implement and one more join we do have anti join. This is simply you can go with full outer minus inner join. Then we will be coming with anti join. Full outer minus inner join deals with anti join. What is anti join? The dissimilar elements, these three, will be taken into a new table, will be joined in new table. Wherever the similar elements are there, they are going to be discarded. This is just like a XOR operator. In XOR, what happens if there are 2 zeros or 2 ones, then the value is false, and wherever the value is dissimilar, true, false, false, true, there it is true. So XOR operator is going to be performing in anti-join. We do have Cartesian product. Cartesian product is nothing but if you are going with A cross B, then each element in A with every element in B. If you are going with 4, all the 3, 5, 8. If you are going with 5, 3, 5, 8. If you are going with 9, 3, 5, 8. That is the output in the joint Cartesian product. So how these joins are going to be performed in MapReduce? So one of the example which we are going to see is reduced side join patterns. In reduced side join patterns are treated as the most typical join which takes more time, but as per the implementation part, it is the one of the simplest one to implement. It has advantage as well as limitation, takes more time to execute but simple to implement, and as well as reduced side joins can be applied used to come up with any of our joint pattern, any of our joints. It might be inner, outer, anti or Cartesian product, whatever joints which we had discussed. All the joints can be implemented using reduced side joints. So in which particular intention, at which particular position or in which particular type we can go with reduced side join. When we are dealing with large data sets and when you have to join these large amount of data sets, then we can go with reduced side joins. At the same time, what is the motivation behind coming up with reduced side join? First thing is reduced side join is the most easiest implementation in design patterns to implement joins, as well as it works on data sets which are large, complex and which you want to make as one using joins. These are the two things or two motivations where we can go with reduced side join. And applicability, where you are dealing with multiple data sets, and at least in multiple data sets one particular field should be common in all the data sets. And the second thing is if you are executing join operations, then reduced side join design patterns are going to be preferred the most. Coming to the structure, how it gets executed, we do have two data sets over here, data set 1 A and B. We do have mapper, we do have reducer and input splits and output file output file, where the data set A has been partitioned into a certain input splits, as we had discussed in our previous session in input and output format. The blocks are going to be splitted up into input splits and they are going to be taken over by record reader, and key value pairs are going to be generated. Those key value pairs are going to be sent to your mapper, on which they are going to apply their logic. If you are going to focus on the first data set, it has retrieved a user Bob. The key over here is the name of the user, that is Bob, and MD is nothing but its designation, which is treated as the value from first data set. Coming to the data set B, we do have input splits, and mapper, after performing its logic, it has taken the key as same as per the data set A, whereas this you may treat it as the count of employees who are working in that particular organization, 37 and 33. So we can apply shuffling and sorting phase. After shuffling and sorting in reducer, they are going to club these things: Bob MD 37, Bob MD 33, and this is going to be taken, which will be stored in a particular output file. This is a whole structure where we are going to come across all these phases while implementing join patterns on reduce side. So the example which we are going to focus is, first we are going to take a users.xml file, and secondly we will be taking comments.xml file. On these two data sets we will be applying reduce side join, where these are the steps which we are going to make. Firstly, we will be creating two mapper classes. Till date we are working with only one mapper class and one reducer class, but in joins we are going to work with multiple mapper class and two mapper classes, one for your user data to parsing of user data, one for comments.xml file to parse the comments.xml file. Each mapper class provides an output where user ID is treated as the foreign key, and user ID will be common in all in these two data sets, which is treated as key. And once the mapper produces the output, it will be sent to the reducer, and in reducer class we will be aggregating, or we are going to group based on the user ID, and those values are going to be recorded in a particular output file. So these are the steps which we are going to make it out. And coming to the execution part, this is a problem which we are going to take it up in next session. Thank you.